Hello my dear students, welcome back to NEET World. So today in this session we will be discussing chemical and ionic equilibrium. Okay, so from chemical equilibrium and ionic equilibrium, yes, we can expect one very short answer type question in your IPE class 11th chemistry part. Okay, so look at this is our C60 material. So this is a C60 material designed to score 60 out of 60. Now you can access this C60 material from our MedWorld app for free of cost. Okay, so now you just go to Play Store and download MedWorld app. Okay, so after downloading this, just go to chart section and you mention hi in the chart box, or you mention your class number, like you belongs to class 11th, right? And class 11th IPE MPC. Then our team will guide you how to access this material for free of cost through the app itself. Okay, right. So in the last sessions we have covered the other topics like states of matter is done, stoichiometry is done. Okay, so like that today we will be discussing chemical equilibrium, and you know already this long answer type questions, 8 marks questions are already discussed. Okay, if you haven't watched, go through the previous live sessions in this channel itself. Okay, you will be having IPE sessions for both class 11th, class 12th, for all the subjects. It will be if your MPC maths, physics, chemistry is covered, if your BPC biology like botany, zoology and mathematics, biology, zoology, like biology completely, botany, zoology plus physics and chemistry are also covered. Okay, yes, go to the playlist of this channel and you can watch whatever the subjects you wanted to be learning. Okay, right. So let us start our discussion here. Yeah, so very few questions I have collected based on the previous year papers. I collected very few questions that must be focused first. Okay, so once after covering this very short answer type questions, if you have time, yes, you can look into the other questions also from this chapter. Okay, but first of all you should not skip these questions. See, what is the first question here? What is homogeneous equilibrium, and write two examples of homogeneous equilibrium. See, homogeneous, it means complete reaction, whatever the reaction is taking place, complete physical state should be same. Okay, complete reactant and product physical state should be same. So look at here, the equilibrium in which reactants and products are in the same physical state are called homogeneous equilibrium. See, we are studying about chemical equilibrium and ionic equilibrium, right? So now in this equilibrium reactions, the physical states of reactant and product should be same. Okay, then those reactions are considered to be homogeneous equilibrium. Now in the same manner, if they ask for heterogeneous equilibrium, what you can say? The physical states in these equilibrium reactions, the physical states of reactants and products may not be same here. They have different physical states. Okay, something like gas, liquid, solid, like that. Depending upon the reaction to reaction, that physical states varies, right? Now compound to compound, right? So now here what are the examples you can give for homogeneous equilibrium? See, formation of ammonia. See how this ammonia is formed from N2 gas and H2 gas, right? Now, so this is what we can say Haber's process. With the using Haber's process we can produce this ammonia. So this is the equilibrium reaction here. So one N2 molecule, 3H2 reacting to give 2NH3. Okay, this is a balanced equilibrium reaction. Okay, so now if you observe all the reactants here, gas, N2 also gas, H2 also gas, and ammonia is also existing in gaseous state. So all the physical states are same now, then you can say it is a homogeneous equilibrium. Similarly here I have mentioned two more examples. See here, what are the two more examples I have mentioned here? Check once. Check once, what are the two examples I have mentioned? Yes, so what are the physical states here I have mentioned? Like see, what are the two chemical reactions? H2 plus I2 gives rise to 2HI. So all of these are in gaseous state now. Yes, you can consider this first example is also a homogeneous in equilibrium. So this is in homogeneous equilibrium reaction. Second reaction also homogeneous equilibrium reaction. That's it. Okay, that's it. These are the two examples you need to mention. See, now the second question is what we discussed again. See, what is heterogeneous equilibrium? We discussed it now. So write two examples for heterogeneous equilibrium. Read this statement once. The equilibrium in which reactants and products are in different physical states. What they are saying? The equilibrium in which reactant and products are in different physical states are considered to be heterogeneous equilibrium. Okay. For example, calcium carbonate is a that will undergoes decomposition to give calcium oxide plus carbon dioxide. Okay. So what is happening here? So I will be writing the same reaction to here, just follow this. See, calcium carbonate. So this will, upon heating, what happens? It will decomposes to give carbon dioxide, CO2, like CO2 gas will be evolved here, and other thing we have calcium and one oxygen, calcium oxide plus CO2. So this is an equilibrium reaction now. See, calcium carbonate is in solid state, physical state is solid, and calcium oxide also in solid form, but CO2 is a gaseous state right now. So it means, see, where we are mentioning these physical states, it's standard conditions. Okay. Like room temperature you can consider. So this is the scenario. See, these reactants and products are not having all of them are not having same physical state. See, this is having a gaseous physical state, as remaining two are having solid forms right now. So you can say this is a heterogeneous equilibrium reaction. That's it. So this is how you need to mention. One more reaction is also mentioned here. See, NH4HS. Okay. Decomposes to give ammonia plus H2S gas. Okay, this is a one more heterogeneous equilibrium reaction example. That's it. These are the two things you need to remember. The next one here, third question we have here, define ionic product of water. What is its value at room temperature? Very easy. What do we mean by ionic product? First of all, see, water molecule, if we consider how it will dissociate, it will be undergoing ionization to give H plus and OH. Remember, water molecule, water is a very weak electrolyte. What I am saying? It's a very weak electrolyte, dissociates to give H plus and OH minus ion. Okay. So now read this statement once. Ionic product of water means what? See, it's simple. What are the ions of water? H plus and OH minus. No? So product, it means multiplication we need to do now. So you just take ions, whatever the ions for water we have, H plus and OH minus now. So take the multiplication of the two ionic product of H plus and OH minus is called, like a product of this H plus and OH minus ion concentration is called its ionic product. Okay, that's it. KW we can say. See how they are writing it is a product of concentrations of H plus OH minus ions in the pure water at a given temperature. That's it. So concentration of H plus multiplied with concentration of OH minus. See, product means multiplication only now. Concentration of H plus ion and concentration of OH minus ion. Product is considered to be ionic product of water. That's it. Okay. Now at a room temperature, it means at 25 degrees Celsius if we consider, they experimentally found that at room temperature the ionic concentration of this H plus ion is found to be 10 power minus 7. So how do we get this 10 power minus 7? This is an experimental value we need to remember. Okay, and here OH minus ion concentration also same, because see, when one water molecule undergoing dissociation, we are getting one hydrogen ion and one OH ion right now. So total number of like OH ions and H plus ions are equal right now. So whatever the concentration is there for H plus ion, same concentration will comes for OH minus ion. Therefore the H plus ion concentration is 10 power minus 7. Similarly, OH minus ion concentration also 10 power minus 7. Okay. So now what this ionic product of water value becomes, KW becomes 10 power minus 14. This will be at a 25 degrees Celsius. See, the temperature is again very important factor here. Okay, if temperature changes, the ionic product of water also changes, because this dissociation will be more at a higher temperature, because this dissociation is an endothermic process. Okay, so that's why 25 degrees Celsius, this is a scenario. So that's it. So KW is how much? 1 into 10 power minus 14 mole square by liter square. That's it. It's a concentration of molar square you can say. Okay, that's it. This is how you can simply mention during the exam. That's it. Okay, right. The next question here is, what is Lewis acid? Give one example. What is Lewis acid and what is Lewis base? Give some examples they will ask. It's very easy. I will tell you, just follow me. Just follow me what I am explaining here. See, give me a minute. So just look at here. So just look at here. What is Lewis acid? Give one example. See, a Lewis acid is a substance that can accept electron pair to form a coordinate covalent bond. For example, you can see, I will tell you clearly, just follow me here what I am saying. See, there are some molecules like NH3 is a molecule, right? So NH3, if you see a nitrogen atom of this ammonia, we have one lone pair. Okay, and now this lone pairs, and you can see here what I am writing, BF3 I am writing. What is this? BF3 means boron trifluoride, like 3 fluorines are there like this. Okay, like this you can write. See, around the boron there is only 3 sigma bonds right now. It means how many electrons are there in the boron now in the BF3 molecule? Only 6 electrons are there. It means that one more vacant orbital is present on this BF3 molecule right now. So now to this empty orbital of BF3, nitrogen is donating pair of electrons. Okay, now remember here, the species which accepts pair of electrons is called Lewis acid. This is a species which is accepting a pair of electrons right now. This pair of electrons are coming from ammonia because it is electron deficient, right? It is having only 6, but we know in order to fulfill octet it required 8 electrons, okay, but having only 6, 2 more electrons are required now, so that's why it is accepting a pair of electrons. So this is a species accepting a pair of electrons considered as a Lewis acid. Okay, so BF3 is a Lewis acid. Okay, now whereas NH3 molecule is having lone pair electrons now, so the pair of electrons is donated by this NH3 molecule. So the species which donating pair of electron is called Lewis base. So whereas it is accepting pair of electrons called as Lewis acid, accepting a pair of electron, this one, so consider it as Lewis base. Okay. A Lewis acid is a substance that can accept electron pair to form a coordinate covalent bond. Yes, see, this molecule is donating pair of electrons now, so and that is accepted by BF3 molecules. The bond formed between these two molecules, a Lewis acid and a Lewis base, the bond formed between Lewis acid and a Lewis base is considered to be dative bond or coordinate covalent bond. So what do we mean by dative bond here? The dative bond or coordinate covalent bond is formed when the both electrons to form a bond is donated by one species, then we can consider that bond as a dative bond or coordinate covalent bond. Okay, that's it. This is the example here I have mentioned. Okay, that's it. Okay, hope the discussion is clear. Okay, right. Let us move forward with one more example here. One more question here. Define pH of a solution. How do you define pH of a solution? Then calculate pH of 10 power minus 3 molar HCl solution. Okay, it's very easy and important question. Just follow me whatever I am explaining here. See, definition. What is the definition of pH? The negative logarithm of H plus ion concentration to the base 10 is called pH of a solution. So it's simple. pH is equals to negative log of concentration of H plus ion. This H plus ion concentration should be expressed in normalities. Okay, that's it. Negative logarithm of concentration of H plus ion is considered to be pH of that solution. Okay, so now pH is equals to minus log, what is the concentration of H plus ion mentioned here? 10 power minus 3 right now. So you can 0.001 means how can you write 10 power minus 3? We can write now. Yes, 10 power minus 3. That's it. So that's it. We are done with the question. See, if there is something like this, log x power y we have. So how do you write this? You can write y log x. You can write it as y log x. Okay, y log x you can write. If it is log x to the power y, it is, you can write y log x. It means this power you are writing here as a coefficient. Okay, so the same story I am applying here. See, here minus 3 is there. I can write here is a coefficient. So minus of minus, it becomes a plus 3. Log 10. Okay, so what is the value of log 10? It is 1 right now. So your pH value will be 3. That's it. This is the answer for the question. So this is how you need to calculate. pH is 3. Okay, hope the discussion for this question is also clear, right? If this is clear, just click on the like button. If there is any confusion, write in the chat box, I will be looking into it. Alright, next one here. Try to calculate this question, try to calculate this and tell me what is the pH of the solution. Yeah, so anyone who are watching can answer me in the chat box. Yes, so how can you answer this? See, the pH of 10 power minus 8 molar HCl solution. See, whenever the concentration of acid is given greater than 10 power minus 6, okay, less than 10 power minus 6, what I am saying, whenever the concentration of H plus ion is given less than 10 power minus 6, then you can consider, see, what is the pH formula we are writing? pH equals to minus log concentration of H plus ion present in that solution right now. So now if I say there is a solution here, there is an acidic solution. So solution means what? There will be acid plus water. Both of the things are there now, acid plus water. We know the concentration of H plus ion that comes from water is taken as 10 power minus 7. Okay. See, water itself giving 10 power minus 7 as a concentration of H plus ion to this pH of the solution. Now if the acid concentration value is less than this value, less than the value of water, then what you can say, you need to take H plus ion concentration that is coming from acid as well as from water. So you need to take sum of those two values and you need to substitute over here. Only if this value is acid concentration value is greater than 10 power minus 6, you no need of taking this water H plus ion concentration. But if the acid concentration here, if you see 10 power minus 8 is there, that is less than the concentration of H plus ion that is coming from water now. So it means you should not ignore water H plus ion concentration coming from water. So you need to add concentration of H plus ion coming from this HCl as well as concentration of H plus ion coming from this water. So now what is the total H plus ion concentration here? Total H plus ion concentration is H plus ion concentration that is coming from HCl acid plus H plus ion concentration that is coming from water. Okay, so some of these values you should substitute over here. Okay, that's it. So now what is the H plus ion coming from water? Ion like acid, that is 10 power minus 8, and from water we know at 25 degrees it is 10 power minus 7. See, 10 power minus 7 is bigger than 10 power minus 8. So you should not ignore this value. Okay, so now what happens here? See, you can write it as 10 power minus 7 as a common factor. Okay, so in the bracket it will become 1 and this will become 0.1. So 1.1 into 10 power minus 7 is the total H plus ion concentration. What is the total H plus ion concentration we are getting? 1.1 into 10 power minus 7, the total H plus ion concentration for this 10 power minus 8 molar HCl solution. Okay, up to here it is clear now. Now apply minus log on both sides. What happens? pH is equals to minus log concentration of H plus ion. It means minus log of 1.1 into 10 power minus 7. Okay, so this is like A into B format na, log of A into B format. So what you can write here? So here I have already mentioned, you just see here what I have mentioned here. So see, minus, I am taking minus as a common factor here outside, and open the bracket, log A into log A, see log of AB is there. So you can write log A plus log B. So log of 1.1 plus log of 10 power minus 7. Okay, so this 10 power minus 7 you can write it as a 7 now. So minus 7 at the coefficient you can write now. Already I explained like log A power B is there means B log A we can write. So based on that you can write this value, we multiplying with the negative sign it becomes 7 minus of this value. So that is 0.04. Okay, that's it. 7 minus 0.041 is 6.959. Okay, so that will be the pH of the solution. So remember, pH of any acid, like I mean say here HCl we are taking now, pH of any acid, whatever the concentration value they are mentioning, always it will be less than, always pH less than 7. Okay, what I am saying, pH will be always less than 7 only for acids. Whether this value, see if you directly take this value into the formula as H plus ion concentration, what will be the answer? You are going to get minus log of 10 power minus 8. It means you are going to get pH as 8. So pH 8 means it's the basic medium, no? So it means your answer is wrong. So do not substitute like this. This is the proper way of solving the question. Okay, so do not do like this. Always follow these steps whenever you have H plus ion concentration less than 10 power minus 6. Okay, hope it's clear. Now remember, acid H plus, I mean acid pH is always less than 7. Okay, this is the steps to be followed here. That's it. And one last question here we have is pH of 0.01 molar NaOH. Guys, these last 3 questions whatever we did, these are equally important if you are preparing for NEET, JEE and EAP set exams. Okay, yes, same model questions you can expect in your this competitive exams also along with your IPE exam. Okay, so now last question you can see here, calculate the pH of 10 power minus 3 molar NaOH. See, NaOH is acid or a base? It's a base, right? So it means this concentration is a value for OH minus ion, that is not for H plus ion. So what is the concentration of OH minus ion we will get? So it is 0.01 means 0.001 means 10 power minus 3 we can write. This is the OH minus ion concentration. Now you need to calculate, whenever you have OH minus ion concentration, directly you calculate POH. What is the POH you will get? POH equals to minus log of OH minus ion concentration. Okay. So from here what you can say? From here what you can say? So here minus log of 10 power minus 3. So this will be 3. So POH is how much? It is 3. So POH is 3. Now at 25 degrees Celsius, see there is no temperature mentioned, means consider this scenario is at room temperature, that is at 25 degrees Celsius you can consider. So at 25 degrees Celsius, pH plus POH, sum of pH plus POH is equals to 14. Total value will be 14. Now I want, see they are not asking POH, they are asking pH now. So now pH is equals to 14 minus a POH you can write. That is 14 minus 3. So your value will be 11. So this is the pH of this solution. pH of the solution is 11 for this 10 power minus 3 molar NaOH solution. That's it. So this is how you need to solve. Yes. So these are the 7 questions to be focused from chemical and ionic equilibrium for your 2 marks questions in your IPE exam. Yes. Now if you have time, yes, you can solve other models also, but these are the must to do questions for your 2 marks answer. Okay, I hope this session is very helpful for your preparation. Now if you like this content, please share with your friends, and if you are new to this channel, click on the follow button. Okay, and also you can watch the other videos we have discussed for other like topics of this chemistry part. Okay, thanks for watching. Stay connected. Thank you.